Buenos dias a todos. My name is Clovis. I'm delighted to be here with you again. In our last lesson, we graphed this parabola right here. Now eventually, we're gonna have to move on to other parabolas, since parabolas do come in all different kind of sizes and positions on the coordinate plane. Not just this one. So bear that in mind. For today though, we're gonna address a question that you could very easily complete all your high school math classes without ever knowing the answer to. And that's if you even think to ask it. The question is this: why are parabolas called quadratic functions? Now, if you ain't already found out that parabolas are called quadratic functions, then this videotape might be of limited usefulness or interest. So feel free to click on the thumbs down, because it's not relevant to your life, and get back to your homework. For those of you who remain, parabolas are indeed very frequently referred to as quadratic functions. So if you don't know, now you know. If you ask your math teacher why that is, they really might have an answer, but they equally might not. That's why we're here. To begin, let's talk about word meanings. Now, some of y'all may already know that the quad part of the word quadratic means four. Maybe you in college, you'll be hanging out on the quad. For the sake of clarity, I hope that in the case of your college, that means a space area on the campus that's got four sides to it. And you probably also know that the word angle means an angle. So if you put quad and angle together in one word, it's probably gonna mean something along the lines of four angles. Here go a word that does exactly that, along with a picture of the most famous quadrangle in the history of math: a square. Now right now you might be noticing that quadrangle bears an uncanny resemblance to the word quadratic. That ain't a coincidence. This ain't a language video, but I believe the word quadratic comes from the Latin word quadratus, which means a square. At least we gonna assume that's the case, because that's how Latin is. It's underneath everything. But what's a quadrangle got to do with a parabola, which clearly doesn't have four angles on it? Well, to answer that question, let's bring our attention back to the picture of a square. A type of geometric shape made up of four straight lines connected to four angles. In other words, a type of quadrangle, and therefore closely connected to the word quadratic. Now obviously, this square is doing just fine on its own. But sometimes you want to find something out about a square. Maybe you're buying a house on this square. You want to find out how many inches big the lot is before you buy it. Welcome to math class. Now personally, I ain't got no idea how many inches the side of this square is. But since we're in algebra, I could just say it's X number of inches, because it's unknown. And since all four sides of a square is the same, that means this other side has also got to be X inches as well. All right, how big is a square? Well, you might have learned this part in elementary school. The area of a square is length times width. In other words, in this case, this side times this side. X times X, X squared. Oh, did you hear that? I accidentally said the word square again. The process of timesing a number times itself is known as squaring. We're looking at a square. It would seem that the process of timesing numbers and squaring them is intimately connected to figuring something out about a square. It's very interesting. Anyway, let's take this X squared, put it on a graph. Don't worry about the reason right now. Now, since you could put an input into this X squared expression and get a single output out of it, it's a function, not just a way to say how big a square is. So Therefore, we're going to refer to it as function f of x equals x squared. Then we're going to graph it. All right, here go the input numbers. 0 in place of x. 0 squared is 0. 1 squared is 1. Negative 1 squared is also 1. 2 squared is 4. Negative 3 squared is 9. And now we graph. 0 over on the x, 0 up on the y. I guess that's right in the center. 1 over, 1 up. Negative 1 over, 1 up. 1, 2 over, 1, 2, 3, 4 up. Negative 3 over 1, 2, 3, 4, 5, 6, 7, 8, 9 up. And connect the dots very carefully. There you go. Parabola. Now, it might not have the shape of a square, but it definitely has a connection to squares because the way we got it here in the first place was by dealing with a square. But now that it's on a graph and clearly ain't no part of an actual square, it needs another name. Therefore, apparently, it's a parabola. In conclusion, the fact that this parabola is also known as a quadratic kind of makes sense, considering it was generated through the process of trying to figure something out about a quadrangle. Now, that ain't the whole story when it comes to the connection between parabolas and the geometric shape of a quadrangle, in particular, a square. But yo, that's life. We ain't got the whole story. We living in the world where the story is never complete. Have a wonderful day. Don't forget your math homework.